Okay guys, now let's look at this example before us that says the integral of 0 to infinity x raised to power 3 exponential minus 4x dx. Now if you actually look at this very well, you will find that this representation is, we cannot actually use gamma function to solve it. Why can't we not use a gamma function to solve it? Now if you look at it very well, if we compare it to the actual representation of gamma function, which is these are the two representations of gamma function I gave you, and I said they're actually the same. I gave you gamma n is equal to integral coming from 0 to infinity s is to the power n minus 1 exponential minus x dx, and I also gave you gamma of n plus 1 is equal to integral coming from 0 to infinity gamma times s to the power gamma n times exponential minus x dx. So these are the two representations of gamma functions I gave you, and I said they are actually the same. So now if you look at this one, if you look at the second representation, which is giving us gamma of gamma to infinity. If you look at the second representation, which I'm about to write, which says that gamma from 0 to infinity x raised to power n exponential minus x dx, and compare it to the question we are given, you see that they are a lot different. Why are they different? Because the exponential here is having just minus 1x, but this here right here is having just minus exponential of minus 4x. So we can't actually use gamma functions to solve it, but we can just do one thing. There is one thing that we can do, that we can easily express, so that we can easily express this exponential function to be a single variable, just like this. So just like the main expression. So now let's take minus 4x to be y. So let's take 4x to be y, because if 4x is y, then we'll be having exponential of minus y, which is a single variable. Are you understanding what I'm trying to do? So whenever you come across something like this that is not in line with the general representation of gamma function, try to express it to fit into this. So for me to express this now to fit, because this is s raised to power n and this s to power 3 fits in, then if I compare this to this, now you see that there are two different variables. So now let's say let y equal to 4x, right? So now let me differentiate y. Differentiating y, this is dy dx gives me 4, right? So and from this place, when y is equal to 4x, x is equal to what? Y over 4. Now, as I'm expressing this to be a function of single variable, all the variables are changing to the variable I'm imposing on that integral. So now let's the equation says integral from 0 to infinity x raised to power 3 exponential minus 4x dx, right? So now since I said let y be equal to 4x, so this can now be written as integral from 0 to infinity exponential 3 exponential minus y dx. So since I said y is equal to 4x, and that means x is now equal to y over 4. So substituting x here into this, also will be having integral from 0 to infinity y over 4 x raised to power 3 times exponential minus y dx. So you see, all has been expressed as y variable except my dx. That is why when I differentiated it, I had dy over dx equals to 4. So let me make the x here subject of formula. Since we're having dy dx is equal to 4, the x is equal to dy over 4. So substituting it back here, also replacing the x with this, we'll be having integral come from 0 to infinity y over 4 raised to power 3 exponential minus y dy over 4. Right? So now all our variables have been expressed uniformly. Now let's just simplify what we have. So simplifying what we have, this is 1 over 4, right? So 1 over 4 goes at the back of the integral sign. And this is also 1 over 4, but this is 1 over 4 raised to power 3. So let's split this up. This is y raised to power 3, and this is 4 raised to power 3. And as this is times minus exponential minus y dy. Then taking this all back, so this is 4 times 4 raised to power 3. The rule of indices, this is 4 raised to power 4. Integral comes from 0 to infinity y raised to power 3 dot exponential minus y dy. So if you can see if you can look at this new integral we're having now, if you can look at this new integral we're having now, you see that when we match it up to the original integral function, you see that this is having a single variable. But if you look at our initial question, it's having minus 4x, and if you look at general representation of gamma function, it should have a single variable. So now we've easily imposed a new variable, thereby expressing it as a single variable. So now we can use this to solve or to get our gamma function. So looking at this variable, these are our actual question, right? And we established a formula that says to equate it to a single variable, which we had to be integral from 0 to infinity y raised to power 3 exponential minus y dy. So, and from this we compared it to the general representation of gamma function of n plus 1 to be integral from 0 to infinity x raised to power n exponential minus x dx. So if you look at these two integrals, they're actually the same, they're actually in line. Then if you compare two of them, my n is equal to 3. Now don't look at it there and say, okay, this one is y, this one is x. No, they're actually the same thing, because I'm just trying to relate it or compare it together, because this one is having a single variable and this one is having a single variable. So we've related it to the original representation of gamma function. So this is n equal to 3. So now, and it says that gamma n plus 1 is equal to this. So gamma of 3 plus 1 can be equal to gamma from 0 to infinity y raised to power 3 exponential minus y dy, right? Is actually the same thing, or it can be said, but since we related it from x to y, that's why we are using something like this. They are actually, the issue is not the variable itself, but the representation, if it looks alike, because this can be m, this can be another alphabet. So the issue is if the representation looks alike, or if the representation is in line with the general expression. So from this now, and we know that gamma of 3 plus 1 is equal to 3 factorial. That's how we got 3 factorial. So but from our original equation, from our original solution to when we express this to be a single function, we are having 1 over 4 raised to power 4 integral 0 to infinity y raised to power 3 exponential minus y dy. So my integral comes from 0 to infinity of times x raised to power 3 exponential minus 4x dx will be equal to, now since we the integral from 0 to infinity exponential 3 x raised to power 3 exponential minus 4x dx gave me, I arrived at this point. Right, this is one. I arrived at this point, which is equal to 1 over 4 raised to power 4 integral of 0 to infinity y raised to power 3 exponential minus y dy. And we calculated the value for this to be 3 factorial, right? So this gives me 3 factorial divided by 4 over 4. Then this gives me 6 over 4 over 4. So this, I can actually leave my answer as this, or you can easily just really express this indices as a normal figure, but you can leave my answer as this. So this is my answer for the question or the example we solved. So now on our now next stage, we'll be going deeper on how to calculate the gamma function when we have a fraction. So now thank you guys for watching, and please do so well to subscribe. Peace.